Hello, myself Dr. Shaila Dinkar Apte. We continue with chapter number 2, that is with properties of continuous time and discrete time signals. So here we go. Now let us define what are energy and power signals. We had introduced energy and power signals saying that if the signal is having finite energy and it is existing over some finite duration, its energy is finite, so we say that it is energy signal. This means that energy signal must be existing over the finite duration. Similarly, if the signal is having infinite duration and its energy becomes infinite but average power remains finite, then it will be called as the power signal. So suppose we consider any sinusoid. This sinusoid is existing between minus infinity to infinity, so the total energy of the signal is infinite. But how to calculate the average power? It is the power of one cycle of this signal and that will be finite. So in this case we term this as the power signal. Now suppose some signal exists over a finite duration in time domain, that is it is time limited, then we'll say that it is the energy signal. This I have plotted Gaussian pulse. Actually the Gaussian pulse it does exist from minus infinity to infinity also, but the amplitude is very small. We can say that it is curtail and it exists between -4 to +4. So we can say that the energy of the Gaussian pulse is finite and hence it is the energy signal. Now what is the significance of this energy and power signal? So we'll have to understand first whether the signal is energy signal or power signal, and accordingly we can find out the frequency content. So if it is a power signal, we'll have to calculate power spectral density, and if it is energy signal, we'll have to calculate energy spectral density. Now we'll consider further the operations on the signal. So even if it is continuous time signal or discrete time signal, we will have to see different operations, those we can carry out on the signal. First one is time shifting, time reversal, time and amplitude scaling, and then addition and multiplication of the signal. So we start with time shifting property. Now, sometimes what happens is we would like to compare the two templates, and you find that the templates look identical but they are shifted in time. So, in this case, in this particular time shifting property will come for help. So, if I write x of t minus capital T, then the corresponding signal xt is shifted towards right by capital T samples. If I write x of t plus t, then the signal, same signal xt is shifted towards left by capital T units. Okay. So here we see how it is. So this is the signal xt that is plotted. It is existing between 0 to t. Okay. Now we consider the shift towards right by one sample. Shift towards right by one sample. That means the signal that was starting at 0 will now start at 1. So it will start at 1 and it will end at 3. This is shifting towards right by one sample. It is represented as x of t minus 1. Now shifting towards left by one sample, it is represented as x of t plus 1. In this case, the signal, this particular signal xt is shifted towards left. So instead of starting at 0, it will start at minus 1. So minus 1 to plus 1 it will exist. This will be called as x of t plus 1. This is what is called as time shift. Now what is the physical significance of time shifting? As we understand, if we have two templates and we find that the two templates are almost identical except some time shift, then what we can do is we can slide one signal over the other and find out the correlation, or you can directly match the signals by using the time shifting. Time shifting property is very useful in template matching or pattern matching problem. Now consider the time reversal property. Time reversal means if the signal is represented as xt, I want to plot x of minus t. x of minus t means what? Corresponding signal xt that is existing will be inverted with respect to this y-axis. So if you invert this with respect to time axis, you get minus t. So this is what we call it as the mirror image of the signal. X of minus t is the mirror image with respect to this y-axis. Now, what is the physical significance of time reversal? When we are calculating the convolution, the first step in the convolution is the time reversal. Now, this time reversal operation means taking the mirror image, and this we can easily do it if we understand what is the time reversal property. So, let's move ahead. Time and amplitude scaling. Sometimes what happens is there are two templates and the two templates look similar, only thing is there is a change in the time scale. So one is having maximum amplitude of 1, another is having maximum amplitude of 2, that's the only difference. Then in that case what we can do is we can normalize both the signals and then compare. So that will be called as amplitude scaling. We also have what is called as time scaling. So for example, suppose I utter some word called as word, let us say. So I utter word, then I utter word. So the time duration for which this signal exists is different in both the cases. So there is what we call it as the time scaling. So let us consider amplitude scaling first. So this is the signal xt which is having maximum value of 1. Now consider 2xt. 2xt means the corresponding amplitude is increased by a factor of 2. Here the amplitude is increased by a factor of 0.5. So it is made half. So this is what we call it that amplitude scaling. This has a normal meaning, so we can easily understand that. Now consider time scaling. Now if I, instead of xt, if I write x of 2t, what happens is I am scaling this time by a factor of half. So if this is existing between minus 2 to plus 2, now it will exist between minus 1 to plus 1. Sorry, it has to be minus 1 here. So minus 1 to plus 1. And if I write x of t by 2, corresponding time axis is multiplied by 2. So here if the signal is existing by minus 2 to plus 2, it will exist here between minus 4 to plus 4. So in this case, it is dilation in time, and here it is scaling means it is shrinking the time. Now this particular shrinking, time shrinking and time dilation property is being used in wavelet transform. So later on when we study wavelet transform, you will understand that there is a mother wavelet, that is the main function, and there are scaled and translated versions of the mother wavelet called as the child wavelets. So we'll come to it later on when we consider wavelet transform. But for the time being, you remember that this is time scaling, and here this is time shrinking, here this is time dilation. Okay. Now what is the physical significance of amplitude or time scaling? Again, when we consider the compare the two templates, let us say that there is only the difference in the amplitude. What we can do is we can normalize the two signals and then compare. So after normalization, what happens is the maximum amplitude for both the signals will be normalized to 1, and then you can compare, because otherwise the signals are the same. And if it is a time scaling, what you will have to do it, one particular word is uttered faster, another word is uttered in a slow mode, then the time duration required for utterance of the same two signals, same two words will be different. So in that case, we use what is called a time warping. So in time warping, we try to correspondingly map the start of the utterance in both the cases and end of the utterance in both the cases. That is what is called a time warping. Now let us see how this particular operation is to be carried out. So suppose this xt is defined like this. It is 2t plus 2 between minus 2 to minus 1 equal to 1 between minus 1 to plus 1 minus t plus 2 between 1 to 2. So it is like this, minus 2 to minus 1, between minus 1 to 1 it is equal to 1, and between 1 to 2 it is decreasing and becoming 0 at t equal to 0 elsewhere. Now I want to plot t of 2t minus 3. So in this case, firstly what I will do is I will try to plot t minus 3. So I will do shifting first and then I will do time scaling. So in order to execute shifting, what I will have to do, x of t minus 3. So shift the signal right by 3 samples. So this is 1, 2 and 3. So now the signal will start at 1 and the signal will end at 5. 2 plus 3, that is 5. So this is x of t minus 3. Now I will do time scaling. I want to write x of 2t minus 3. So I'll have to scale the time by a factor of 2, means actually the time scale will have to be multiplied by half. So 1 will now become 0.5, 2 will become 1 and maximum value of 5 will become 2.5 here. Right, so this is how the time scaling takes place. This is called as the precedence rule. Precedence rule says that you execute shifting first and then do time scaling. Right. Sometimes the person may do time scaling first and then execute time shifting. But if you want to do so, you will have to write this x of 2t minus 3 as x of 2 inside the bracket t minus 3 by 2 and then execute the way you like. You can execute the time scaling first and then do the time shifting. Right. So unless the bracket is there, here there is no bracket for t. So if I write it as 2 into t minus 3 by 2 in the bracket, then I can execute the time scaling first and then the time shifting. But if it is like this, you will have to execute time shifting first and then the time scaling. This is called as precedence rule. And if you don't do that, you will end up with wrong result unless you put a bracket, as I told. If precedence rule is not used, what I will do, x of 2t minus 3, I will write it as x of 2t minus 3 by 2. So what I will do, I will do scaling first. So the scale means it is minus 2. This is scale is 2 here, isn't it? For t the scaling is 2. So what I will do, minus 2 will be scaled by 2, so it becomes minus 1. 2 will become plus 1. So this I have done scaling first and now I will do the shifting. Now shifting by what? Shifting by 3 by 2 towards right. So 3 by 2 means minus 1 plus 1.5, so it will become 0.5. And 1 plus 1.5, so it will become 2.5. So entirely shift the signal towards right by 1.5. So again we are getting the same result. So if you don't want to use the precedence rule, now what you will have to do is you will have to put the bracket and then you can do scaling first and then you can do shifting, right? Otherwise use the precedence rule only. That is the better way to understand. Now second example using the precedence rule. Here this rect function is specified and you are supposed to draw x of 3t plus 2, x of 2t minus 1, x of 2 into t plus 2. Okay. So this is a rect function that is plotted between minus 1 to plus 1. Now I have to do x of 3t plus 2. So using precedence rule, what I will do? I will execute x of t plus 2 first. T plus 2 means it is shifting towards left by 2 samples. So this is 1. So where it will go? 0, minus 1. So this line will go at minus 1 and this line at minus 1 will go at minus 3. So this is x of t plus 2. Now I will have to scale by a factor of 3. Scale the time axis by a factor of 3. So x of 3t plus 2 will become what? This is minus 3 divided by 3. So it will become minus 1, minus 2 by 3 and minus 1 by 3. Right? So this is just the scaling by a factor of 3 for the time scale. Do you understand? Next, consider x of minus 2t minus 1. So firstly, I will have to execute x of minus t minus 1. If I want to have x of minus t minus 1, firstly I must know what is x of minus t. But in this case, this x of t and x of minus t will be the same because the signal is symmetric. Right? So x of minus t is same as x of t. Now consider x of minus t minus 1. Minus 1 means it is to be shifted towards right in case when this t is positive, but this is minus t. So minus t minus 1, so it is shifting left by 1. So when it is shifting left by 1, this minus 1 will tally with minus 2 and minus 1 will tally with 0. That is, the entire signal is shifted left towards left, shifted left by 1 sample, minus t minus 1. If it is t minus 1, I would shift it towards right. If it is minus t minus 1, I will shift it towards left. This you remember. So minus 2t minus 1. So again the scaling for time by a factor of 2. So minus 2 will become minus 1, minus 1 will become minus half, and so on. This is easy. Now consider 2 of x of 2 into t plus 2. So I can expand the bracket directly. I can write it as 2t plus 4. So I'll first consider x of t plus 4 and then I will consider t plus 2t plus 4. So if I consider x of t plus 4, this is xt. I have to execute x of t plus 4. So I will have to shift left by 4 samples. So this 1 will be shifted by 4 samples, 0, minus 1, minus 2, minus 3. So this 1 will coincide with minus 3 and minus 1 will coincide with minus 5. So minus 5 to minus 3, this is x of t plus 4. Now scale by time scale by a factor of 2. So 5 will become 2.5, minus 3 will become minus 1.5. This is easy, isn't it? Yes. So let us consider the operation of discrete time signals now. Now this is suppose some x of n that is specified. Now if I want to specify x of 2n, x of 2n means scaling the time axis by a factor of 2. Now in this case it is also called as downsampling. Downsampling means take alternate samples. So take this sample at 0, then take sample at 2, then sample at 4, then sample at 6, then sample at 8, and then sample at 10. So this is how it is done, downsampling. Now if it is x of n by 2, then I'll have to do the reverse operation. This is called as upscaling. Rather than downscaling, it will be upscaling. For upscaling, what you do, the signal that is at the signal sample that is at 2, that is at 1 will now be shifted at n equal to 2. The signal sample at 2 will be shifted to n is equal to 4. And what will happen at 1 and 3? You just have to insert zeros. So insert zeros in between and you elongate the signal xn, and in this case you shrink the signal xn by downsampling. So take alternate samples or insert zeros in between every two samples, right? This is called as upsampling, this is called as downsampling. Now let us see operations on discrete time signal. So let us say if I want to write x of n plus 2, n plus 2, naturally it is shifting left by 2 samples. So whatever signal we had from 0 will now be existing from minus 2. Is that right? And it will not go up to 10, but it will go only up to 8. Now x of 2n plus 2, that means scale the n axis, that is time axis, by a factor of 2, means you do downsampling. So signal sample at minus 2 will appear at minus 1, then 0th sample, the signal sample at 2 will appear at n equal to 1, then the signal sample at 4 will appear at 2, then the signal sample at 6 and 8 appear here. So it is downsampling, means take alternate samples. Is that okay? Now this is slightly a complicated example I am trying to explain you. So I have some x of t. This is some time domain signal that is specified between 0 to 3 and it also exists between minus 1 to 0. Okay. Then I have specified yt, another signal yt. So this yt exists between minus 2 to plus 2 and it has this particular shape. Okay. Now suppose I want to do x of t plus y of t. So I want to add up the two signals. Now consider the duration between minus 2 to minus 1. Minus 2 to minus 1, only this yt is present. So when you add, yt will appear as it is. Okay. Now Between -1 to 0, this xt is there and yt is also there. Yt has a value of fixed value of -1, and on this -1, this particular signal of xt will superimpose. So this is -1, and on this particular signal will superimpose. Okay. Now between 0 to 1, the signal is existing between -1 to 0, and here it is existing between 0 to 1. So see what happens. At 0, what is the value? At 0, here it is, in this case it is -1, and in this case it is -1. So -1 plus -1, it will become -2. And at x is equal to 1, what will happen? The signal is 1 here, it is also 1 here, so 1 plus 1, it will add to 2. So between -1 to +1, it will vary from -2 to +2, right? Now between 1 to 2, this is 1, this is also 1, so 1 plus 1, it will add to 2. 1 plus 1, it will add to 2. At 1, it is equal to 1, and here it is 0, so it is 1. So it is varying between -2 to 1. Sorry, it is not from -2 to 2, but it is -2 to 1. And between 1 to 2, it will be equal to 1 plus 1, so it will become 2. Now see, between 2 to 3, this signal is not existing. Between 2 to 3, only this exists, and it is decreasing from 1 to 0. So it decreases from 1 to 0. So you just have to add segment by segment and see the result. Now see here, this is subtraction, xt minus yt. So here this -2 to -1, this xt is not existing, only yt is existing. You take xt minus t, so minus yt, so yt will invert, right? Now between -1 to 0, this is varying like this, and this is existing, and it is equal to -1. It will be negative, minus of -1, so it will be equal to 1. So between 1 to 0, it will vary like this. Then between 0 to 1, this is going from 0 to 1, and this is going from -1 to 0. So at this point 0, it is equal to -1, and at this point it is equal to +1. So when you subtract this from this, it will result in a 0. This is 1, this is also 1 between 1 to 2, so it is 0. Now in this case 2 to 3, this is not existing, so it will be just xt like this. So you just have to concentrate on a particular range and see what will be xt minus yt. Okay, I hope it is fine. Now consider the multiplication, example for the multiplication. So same is xt, same is yt. Now I have to calculate xt multiplied by yt. So in this case, see, -2 to -1, -2 to -1. This is not existing, this is 0. So 0 multiplied by anything will be 0. Now this is -1 to 0, it is varying like this. -1 to 0, it is -1. So minus of minus will become plus, and it will vary between 0 to 1. Now here it is 0 to 1, it is varying between 0 to 1. Here it is varying between -1 to 0. So if you multiply plus with minus, it will become minus. So what will happen? Just see, it is shown between, it is like this and this. So how this is obtained, can you understand? Just see, between 0 to 0.5, okay, 0 to 0.5, how much it varies from? See, this is maximum value it attains, and that is equal to, I think it is 0.5. So 0.5, 0.5. Now this is 0.5 to 1, and this is 0.5 to 1 again. So 0.5 to 0, 0 minus 0.5 to 0, it will vary. So here it is having a maximum value, as you can see. Then between 1 to 2, this is 1, 1 to 2, this is 1. So when you multiply, it will be equal to 1 only. Between 2 to 3, this is existing, this is 0, so it will be 0. So you just have to do part by part and see what will be the output in this case. So in this case, it is xt into y of t minus 1. What is y of t minus 1? Shift this yt towards right by one sample. Alright. And then just take the product sample by sample. So here this is 1 and this is minus 1 to, it is varying between 0 to minus 1. So it will vary between minus 1 to 0 because this is 1. Then this is between 0 to 1. This is equal to minus 1. So this plus and minus will become minus. Now in this case it is varying between minus 1 to 0, but this is 1. So minus 1 to 0. This is 1, but this is varying between 1 to 0. So it will vary between 1 to 0. So concentrate on a particular interval and then just go on multiplying. This is x of t plus 1 into y of t minus 2. X of t plus 1 means I'll have to shift this left towards left by one sample. X of t minus 2 means I'll have to shift this yt by two samples and now take the product. For this taking the product, here it is 0 in this case, so here it will be 0. Above 2 also it will be 0 because this is 0 after 2. So only that interval that is common overlapping is 0 to 2. So 0 to 1, this is 1, this also 1, so it will be 1 here. Between 1 to 2 it is negative, 1 to 2 it is decreasing, so but it is negative, so it will go like that. Okay, so this is how you are supposed to solve different problems. Now what is the how we do the addition and multiplication for discrete time signals? So it is on similar lines. This is some xn given to you, yn given to you. Now you have to find out xn plus yn. What you do xn plus yn means add sample by sample. So this is 1, this is 1. So the addition will be equal to 2. At 2 it is 2, at 2 it is 1. So 2 plus 1 it will become 3. This is 1. At 3 it is 1, 1 and 1. So it will become 2. This is equal to 2 for 4 and this is 1 4 plus 1 5. Then at 5 this is 1, at 5 this is 1, at 5 it will become 2. So just go on adding sample by sample, that is called as addition. And multiplication also do it sample by sample. So xn when multiplied by yn, because yn is 1 throughout, multiplication of xn into yn will be same as xn. Are you getting it? Now this is x of n minus 1. N minus 1 means shift it right by one sample. Y n plus 2. Yn plus 2 means shift it left by two samples. So x of n minus 1, y of n plus 2. So here below 0 this is 0. So here also it will be 0. Above 5, above 4 this is 0. So above 5, above 4 the product will be equal to 0. And just have to take the product of sample by sample. Okay. So here this is 1, this is 2. So it will be 2 like that. Just go on taking the multiplication sample by sample. Now physical significance of addition and multiplication of the two samples. So this is a basic process used in the convolution. In the convolution, what you have to do is take the mirror image and then go on shifting and go on taking the sample by sample product and addition. Okay, so sample by sample product and addition will give you the convolution, right? So these are the steps basically in the convolution process that we'll understand when we consider the convolution in detail. Thank you so much.